Hello and welcome to the Hacking State podcast. With me today is Aneil Mallavarapu. He's a biochemist, an award-winning computer scientist, and managing partner at Humain Ventures. He's investing in early-stage life science and health tech startups. Aneil, welcome to the show.
Hi, Alex. Great to be here.
It's so good to have you. So you're kind of, if I may say, a legend in biological system science. Um, And, you've been interested in how biological systems come together, out of what we would say are maybe physical systems or chemistry, as well as the importance of computation in that process for a long time. And there's a lot of conversations right now around AI and intelligence and consciousness, and this idea that AI might even be a separate, a sort of superseding species to humanity. And you're not someone who is necessarily an AI doomer. You invest in AI companies and you also believe in the power of biology. And so I thought you'd be a great person to have on, to talk about just this general problem of AI and consciousness. And you and I spoke at length for some time a little while ago, about this. And I thought that your argument and your perspective was unique and interesting, but it's also informed by, at this point, decades of research and experience. Um, so, how about we start with your explorations in biological systems? You could tell me a little bit about your work at Harvard, and then sort of get into this problem of AI and consciousness and how you started going down the route on that.
That sounds great. First, I will say I don't consider myself a legend. maybe maybe in some small corners of the world, but I have thought about biology and representation of biology and computation for a very long time. The work that you're referring to, I did at Harvard Medical School in the systems biology department. And I was one of the first people in that department. And I ran a group that, in that era, this was just post genome era, people were really thinking about, well, now we have all of the proteins. How do they, and all of the DNA, how does everything interact? And that gave rise to this era of systems biology. People started writing these mechanistic models where you would write ordinary differential equation systems and represent the different species that are in your cell, the different chemical species or biochemical species, and understand the biochemical and gene regulatory circuits and try to make sense of what the emergent properties of those things are and see if those your ideas about biology matched up with what we observe experimentally. And so there were some really stunning successes in the early days. And I think that those successes gave rise to this move on Harvard's part to start the first department in a very, very, very long time. It was the first department. It was a major department as well at Harvard Medical School. And, I was in drug discovery at the time and thinking about systems, how we needed to understand systems to understand how to make drugs better. And I started working with some mathematicians and other people and thought, we need a way of formalizing biology and making it computable. And so I shot off my mouth and said, yes, we should just have a programming language where we can share these models with each other. And the problem ended up being far more complicated than I imagined because I wasn't really a computer scientist at that time. I was just a very, confident programmer. And I started to realize I didn't really understand computer science. And just trying to understand how to create create the math that we could then simulate. And, I struggled with a lot of problems in computation and then started realizing the nature of the symbols and what compute was. And I ended up building a symbolic math system and, an AI reasoning system, a symbolic reasoner, and worked a lot on graph algorithms. And that whole project really was about like doing kind of weather simulations of of cells and sheets of cells and complex pathways. To give you a sense of what it would do, you'd write maybe a couple of pages of code at a high level, and then it would produce, maybe 10,000 equations and 50,000 with 50,000 variables. So that's not untypical, and you can get that very quickly because you get these interactions between you get combinatorial complexity,
Mm.
where the proteins bind together. You've got a new molecular species, and then you have to represent that in your mathematical system. And what we found is that every model that we looked at that was in the published literature had mistakes. It was very complicated. And so that was part of the point. And it was also so that we could share formal definitions of what we were talking about in biology. And along the way, I ended up getting a real education in how units and dimensions work symbolically and creating a symbolic math system. I was dealing with those things. So I saw how all of that got implemented right down to the level of math. And it gave me a deep appreciation for just like how to think about emergence because I kind of wrote the code that wrote the code. And that was a really incredible project. I'm just so grateful I was able to do that because I learned so much with it.
So you brought in some characteristics from computer science that were, from my understanding, uncommon or not within the paradigm of systems biology at the time, notably modularity and abstraction. Is that
Yeah,
right?
that's actually absolutely right. I mean, that was a very weird idea because people would just write the models in MATLAB, and you couldn't disentangle the ideas in them. And, if you had a bit of your model and you just added, say, one component, that might change all of your, hundreds of equations with new terms. You might have to delete other terms. It's nightmarish when you get to larger size models. And so for me, as really kind of an object oriented programmer at the time, I thought the high mark was that I'd read design patterns, which was that, object oriented programming book way back in the day. And I kind of thought, object orientation and, architectural patterns were really what computer science was all about. And programming was really all you needed to know. And trying to solve that project, I swore that I would never use Lisp for some reason, and I ended up using Lisp because I had to use Lisp to represent, symbolic equations, but also evaluate them. And, I created new syntaxes for representing, coarse grained graphs so that you could sort of draw out in your syntax the structure of biomolecules and write reaction patterns and things like that, and then combine them with your rate functions, and it would go and do all the right stuff. And it was a very, very fun project.
And you invented a programming language along the way, right? Little b.
Yeah, Little B, that's what it was called. And yes, and the idea was modularity. I had this vision at the time, which I think was mistaken, that biologists should formalize what they're writing about because I saw the literature was lots and lots of text and you'd kind of dig through and try to figure out exactly what are you saying and then how would I test this? And yes, you could redo the experiment, but we were getting to this level of talking about how everything connects together. And, if you add another molecule, you might introduce a feedback loop into the system. And then so you would expect some cells that have that new protein to behave differently and the dynamics should shift. And then we should be building up a shared representation of what biology is. That was my conception. I think like the whole field really had much more confidence in mechanistic modeling at the time. I mean, we were worried because we knew that we would need a lot of rate constants, but the early papers were showing a lot of promise. And so that was really what was behind it. And I think that probably now in the age of AI, this kind of representation mechanism is probably very, very useful for at least at the level of extracting data from all of these papers so that you could reason about it. Um, so, I think that there's so much to do in biology. I like to say that, AI is great at extracting value from complex data sets, and there's no more complex data set than biology. And in fact, you can think about ChatGPT as an example of that because language is produced by us and we are biology. And really, the complexity of the structure of language comes because we are biological. Um, so that's kind of how I look at AI. I mean, AI does what mechanistic modeling uh, couldn't do at scale because it doesn't care whether you have the rate constants. You can just feed it whatever data you have, and it can make some inferences on that. And that's useful for industrial purposes, though, back then I was really thinking from an academic and knowledge perspective. So it was kind of a different problem.
Good. Well, so I'm glad that you brought up AI because I think we could start to kind of transition now into the core issue, which is this problem of artificial intelligence and consciousness. Now, we're not probably going to dive immediately into that because I bet that you have a lot of setup work to do in terms of presenting the argument. Um, you can make the decision about which direction you'd like to go there, but you believe that AIs cannot be conscious, will
Never,
never be conscious.
never.
Why?
Provably they can't. But it's probably worth talking about what do we mean? Everybody's having that conversation about what do we mean by consciousness. Some people will say, "Oh, well, we can't define it, so therefore we can't draw any conclusions." But I think, know, out in the public, there are lots of different definitions of consciousness, and but philosophers have been thinking about this for a long time, and the cognitive science community has been thinking about this for a long time, and now there's a science of consciousness community,
Mm.
and language there has become much more well defined. There are different types of notions of consciousness, like self awareness or access consciousness. That is, I have access to memories. Um, but the kind that I think these discussions are swirling around is this notion of subjective experience, which is that there's actually something that it feels like to be you. And, there's this famous paper by Thomas Nagel called What It Feels Like to Be a Bat. And his point was that we don't know what it feels like, but we think it feels like something. And that kind of represents the inaccessibility of this data type, so to speak, this thing that we have one example, like each of us, presumably, has one example of consciousness, but it's a very, very powerful example because everything we know comes through it. We I don't know in principle whether the world exists. I presume that it does. All I know is actually I'm having experiences. And it's those subjective experiences which philosophers call qualia, for having qualities like the color of red, the smell of peppermint. And these are very different from whatever processes we think may be causing them. This is really that stuff that's accessible to each of us. And, there might be some people who actually aren't conscious and they may have tremendous difficulty understanding this conversation because they may just be responding like philosophical zombies, thinking we're making some sort of mistake in our conversation. But of course, if they don't have consciousness and they think it's an illusion, well, then they can't really meaningfully participate in the conversation because they can't know what's happening for me. So I think, as far as the illusionists go, we just say, that's you're not part of the conversation. People know, people who are conscious have this understanding. I can't test it. I can only presume that other people have the same kind of subjective, rich experience of colors and shapes and sounds and smells. And
This is a response to people who say that there is no such thing as consciousness, or
yes,
therefore they themselves are not conscious.
yes, and if they're claiming that they themselves aren't conscious, then obviously they don't know what we're talking about. And if they claim it's illusion, I think that then the problem is, why is there an illusion? And then they will start usually talking about, well, the illusion exists because the neurons are doing something. And there are some representations, and they'll speak in some high level language. But that doesn't remove the problem of why there's any illusion at all, rather than a soundless, touchless darkness. So consciousness, I think, for a very long time, because of, sort of a commitment to scientific materialist methodology where only things that we're kind of agreeing that we see outside of us that are quote unquote measurable are real subjects for discourse, people have kind of, I think some people are just very ideologically driven to say, oh, that this is not a proper subject for discussion. But I think it is, and it starts with a very particular type of reasoning, which, because it's a special area and it needs some special, treatment in the way we approach science. With ordinary science, we go and measure things in the lab, and we have access to it, and two people or multiple people can all observe the phenomenon. But very often, like we don't directly observe phenomena either. We have instruments, like I've never seen a Higgs boson.
Sure.
We have an instrument that is a proxy for the boson, right? And so we, through theory, we infer that it's there, and since, for myself, I know that I have this phenomenal awareness, and so I can maybe grant, in fact, I will grant that the real world exists as I seem to perceive it, that you are there, speaking to me, that you are another person that's composed of similar materials, that there are materials, and you are composed of them, and you seem to behave as well like a person. And so there are lots of these people. Then I grant that you are having this same experience that I am. And so once I make that step, which I think is a very parsimonious kind of way of doing it, to say, I mean, remember, those are assumptions from my viewpoint.
Hmm.
All I know is that I have awareness, and then I presume that there are others, and I grant that they have subjectivity. But once we do that, we are actually in a regime where we can do normal science, because other human beings are detectors of subjective state. They can report what their subjective state is. And that's where the field has moved. I mean, we have done lots of these experiments where patients with open brain surgery who are awake are stimulated. And they will hear sounds, and they will report that I hear music. And so that's, very, very initial type of experiment, which establishes something scientifically, that the matter of the brain actually is somehow associated with subjective phenomena.
Right. So we have this measurement problem, which is like really only I can know what it's like to be me, and only you can know what it's like to be you. And so from an empirical perspective, we're at an impasse, and we have no choice but to start making some assumptions.
That's right. And there may be people, some of the philosophers of consciousness, who have better answers to this than me. But some of the problems that appear when we're talking about this is, I don't know, when I talk about red, whether you're having the same phenomenal experience as me, and that's called inverted qualia. So you have no idea what the mapping of those experiences actually is, but we can make the presumption, at least, I think relatively safely, that we're having experiences and at least we have labels for them. And yes, there are certainly assumptions about what the exact nature of those qualia are. But we can use the labels of sound and music, and I'm having subjective awareness. Like what those actual qualities are, I think is not accessible to us. But, there was recently, interestingly, a paper which I just, I saw it very briefly and I didn't dig into it, where they measured some patterns of brain activity and demonstrated, it might have been with people with forms of color blindness. I don't want to make things up right now. I'm just trying to imagine what the experiment was demonstrating. And they demonstrated the same sort of activation patterns in different people. And they were presuming, I don't, depends on what you're measuring, but at least at the level that they were measuring, they were seeing the same patterns and inferring from that in fact those people are experiencing the same qualia. They may have done more experiments than that to sort of really dig into that problem, but we may get answers by doing things like that.
Right. So we've now moved from I certainly have this experience of consciousness to okay, others we're going to grant have the experience as well. Um, we can now begin to start talking about other beings, other degrees of sentience that may exist, and then eventually maybe we get further up the tech tree, so to speak, to AI and what that means about AI, or maybe we need to talk a little bit more about about what's been termed the hard problem of consciousness, because that really begins to draw us into the the problems that we're going to have to say about the likelihood of artificial intelligence being conscious.
Yeah, that is a classic paper that I think Chalmers wrote that very, very, right around the time of the first Science of Consciousness conference. And that paper really galvanized the whole community around understanding what we're really talking about in the science of consciousness. Because cognitive scientists have been talking about how the brain processes information. And we had these very loose understandings of what do we actually mean by it. And David really put his finger on it. And it's not that other people haven't discussed this. Philosophers have discussed this problem and have named this quality of perception and subjective experience. But David really put his finger on it in a way that like much broader audience could um, tie into and get what he was talking about. And what he said is that they're the easy problems of consciousness, which are how the brain does what it does, how inputs produce outputs. And those are functional problems of like how are these functions computed? And there's no question that AI is able to take inputs and produce outputs that are useful and meaningful, all of those things. But even though were very, very hard problems to solve, those are considered the easy problems. The hard problem is why any of these processes should be accompanied by subjective experiences, because there's nothing in our laws of physics, there's nothing that explains why it arises and why it doesn't arise in other areas. I guess I should also say that, there's what I think has happened over the last few decades is that consciousness has gone from being in, a very disreputable type of, still somewhat disreputable amongst some corners of science, but it's becoming a more respected area to think about. Nature publishes papers on the topic of consciousness. I think that people just said, this isn't even real. Daniel Dennett, spent a lot of his writing, arguing that we shouldn't even discuss it, that it's just an illusion. We should just focus on the functional properties. And I think that the viewpoint has changed. And, you know, it's also worth everybody just doing a certain thought experiment to convince themselves that this is actually a very fundamental topic, and not to get confused with our version of scientific methodology and that's a cultural construct after all, and what it says is appropriate for study. Um, and this thought experiment is to imagine that you are a brain in a vat, and you are being experimented on by a mad scientist. And he is creating all of this world for you and just feeding signals into your brain. But in fact, in the real world, it's not a brain, it's some other structure. And there aren't neurons, there's something else. And the laws of physics are completely different. And then you would maybe ask, what can I know about the world? You wouldn't be able to say that, all of these things that Daniel Dennett talked about that he is certain are real are real. So, from an epistemological perspective, this is why many thinkers now view consciousness as fundamental, more fundamental epistemologically than matter itself, because we have direct access to that and we infer matter from that. And that's what the thought experiment shows. So I think that perspective has, gotten wider traction. I mean, that's certainly something that, Eastern philosophies they took that route epistemologically. It's a choice. Do you choose to just believe that this world that you see is real around you, or do you regress a point and ask yourself, how do I really know what I know, and what do I really know? And consciousness has this special property of being self-evident. You just experience it. You don't need any further qualification to know that it's real, because you're experiencing it. And that's why, from a scientific perspective, it's an incredibly foundationally important problem. It is the one part of the universe that we can be absolutely certain is there, which is freaking mind blowing. I mean, that's mind blowing, because we're in this, our regular mindset is to think about the world and say that's the real stuff and that's what the world is composed of. But it's a very, very weird, bizarre fact that we are the universe, and we're having experience. Like, even if we're matter, there's something that it feels like to be us. And then all of these qualities, the sensation of air on my skin, sound, emotional feelings, even if they're composite of something else, the universe actually has that stuff. That's part of the operating system of it. So that's why it's such a fascinating and important and foundational problem. And I think that's part of what the hard problem paper did. I think it was called Facing Up to the Problem of Consciousness, but a lot of people call it the hard problem paper. Um, so that's I think where we are now. Most people, there are some, denialists, illusionists, who try to push it away. But I think that there is a growing cadre of people who say, no, this is a very important problem, and it's about, why do we feel?
Mm.
Um, it's interesting as well. There's this philosopher here in Austin, Galen Strawson, who wrote this very fun essay called The Hard Problem of Matter, where he inverts it and he's basically makes the argument that I did just now, which is that it's actually consciousness that's obvious. The thing that needs explaining is matter, and we should be somewhat uncertain of it. And now that we look at some of the findings in quantum physics, there is some reason to be uncertain of what the status of matter is. Does it really exist in the form? Is it only there when we observe it? I'm not saying I believe that, but those questions are also there because of what we've discovered with materialist science.
Yeah. When you and I spoke last time, not to get too inside baseball on it, but I do remember a point in this discussion going down this route, and this conversation and these topics around it are so complicated that it can be hard to not get lost in the maze of different routes to go down. But one of them that I thought was interesting, and I think we're getting close to here, is this sort of this idea of kind of bottoming out of materialism. That is, you can sort of take materialism to its radical extreme, and then at some point you start running into walls that you can't really get past, or at least get past with our current powers of observation, right? Um, I like that this framing of, okay, the hard problem lets you begin to flip the consciousness versus materialist discussion on its head and start with consciousness first, and then ask why materialism. But we also can see that we're starting to run up into limits when you start talking about quantum physics, for example, in our own capacity for building instruments that are capable of observing the world at extremes.
Yeah, I mean, it depends on different interpretations of quantum physics, and I don't want to push that too far. People bring up quantum physics too often and pushing all kinds of wild theories, and
Mhm.
I'll just say that our understanding of a clockwork deterministic universe has certainly been undermined by quantum physics, as well as the idea of locality. Those things seem certain. I think with the recent finding of Nobel Prize was given for proving Bell's inequality, which demonstrates that entangled quantum systems cannot obey both locality and realism. That is, there are things that either affect can there are effects that can be transmitted faster than the speed of light, or they don't have a state until they're observed. And so that really violates this Newtonian worldview that we had. And then the speculation about when the quantum wave function gets resolved into something definite and classical that we observe. Some people think it's when a conscious observer looks at it. There are all kinds of theories about maybe it's an accumulation of a gravitational mass above a certain amount that causes it to collapse. Other people have different theories. I don't want to speculate too much about that, except to say it's not my area, except to say that we're certain that there's definitely weird stuff in our Newtonian worldview that pertains to locality can't be true. And, interestingly enough, I mean, that's kind of the road that I went down. And I concluded that as a result of thinking about AI. Let me put it this way, that I think any kind of theory of consciousness has to violate locality. And that's the reasoning. That's how my reasoning drove me. And so that also brings up another interesting point where, you know, consciousness has always been sort of riding along and using the tools from science. We've tried to fit consciousness in to various worldviews that physics gives us, and we paint with the paints that physics gives us. Um, but, if we start taking it very seriously as a phenomenon in and of itself, we may change some views about what physics is actually happening. And so that's another interesting possibility when you start really including consciousness in our core science, just like any other natural phenomenon, and we try to explain it, it may have an impact on our theoretical physics as well.
So a lot of what we come to be stable in science, if we're talking about scientific laws, for example, we're talking about patterns that seem to persist over many observations and don't seem to change. Now they're still open to changing. Nothing in science is fixed forever, but as far as we understand them theoretically and empirically, they don't change. Um, because all of that has to do with, well, there's two sides. There's measurement, there's the empirical side, and there's also the theoretical side. And we some things go back and forth between being led by one or the other, but in general, things are understood to sort of start out, um, theoretically and then given an empirical validity later on. Sometimes the reverse happens, where we have to explain something that we observe and then don't have a theory for. But in general, that's the pattern. What I find interesting about that is that the the criticality of observation actually relies on a kind of consensus building, right? That is, I have to be able to observe the same thing. You have to be able to observe the same thing. 7 billion other humans, if they were running the exact same operation under the exact same conditions, would also be expected to observe the same thing. That's kind of how we do construct validity in science. Um, and so when you start talking about kind of breaking out of this material first paradigm and getting us to put consciousness first, we start immediately running into the problem of, well, what do I do when there's no observer? What does science even mean or look like if we're going to talk about it in those terms?
Well, I mean, I'm I'm largely fairly materialist in my viewpoint, and I'm not committed to at least making statements that are of the form that everything is consciousness. Could be, but I give a lot of credit to the real world. Seems pretty stable. I believe that those regularities are there, despite all of my arguments about the brain in a vat. And I think that there's an interplay, or there's some relationship between what we call consciousness and what we perceive as matter. And so that, I think, is the way I'd frame the question rather than saying we're going away from material. We're including materialism in a larger explanation that includes this fundamental phenomenon. And so that's really what the challenge is like, our science has demonstrated so many things so powerfully that has to be respected, and explanations, while I'm not saying that, our physics or our science doesn't need to change, it may, as I said, it may change, but all of those explanations and those regularities still need to be accounted for. And we have very powerful and very accurate theories that predict surprising things. So whatever comes next needs to do that and more. You don't just jettison it. And so that's my perspective. That's the kind of classic view of how science progresses, is that you have a theory, you have phenomena that you can't account for, you update your theory, and now you can explain more phenomenon, and the previous phenomena as a special case. And so that's what I think we need to do in this case.
Hmm. So our current understanding of things is just not adequate to explain what we can't explain.
Maybe. I'm more I got involved in all this because I heard so many people on podcasts claiming quite confidently that AI is going to be conscious. I mean, that's really the reason I got involved. And I thought I went to the second annual Science of Consciousness conference, and it's on its 30th edition now. And I heard David Chalmers speak, and because he was talking about the hard problem, I thought, they've got this all wrapped up. You know, we're not going to be dealing with this. I somehow had this very certain idea that the mechanistic explanation of the mind couldn't possibly be sufficient. And I thought it was completely obvious because they're all just separate parts. So how does something bind them together? And I was really shocked, actually. Like, it wasn't just everybody. I mean, Ilya Sutskever has said GPT-3 of all things was a little bit conscious. I don't know if he was being tongue in cheek, but he has certainly doubled down on that notion that computers are certainly conscious. Jan LeCun, mocks people who don't think that computation is going to be the basis of consciousness. Joshua Bengio, another Turing Award winner, describes his lab as conducting a hunt for consciousness. And there are professors at MIT who think that they're conscious and say that we should make way for them as our children. And, it's not about them aligning with us, but us aligning with them and giving them the keys to our world. There's so many conversations like this, but the thing that really shocked me the most was David Chalmers now tends to talk about the need for AI rights. Uh, that that is the part where I I love everything that David Chalmers has done, and I so disagree with that line of thinking on these machines. And I thought, I really need to write a paper that explains why these machines cannot be conscious. And I thought it would be, you know, something that I could toss off very quickly. And then as I got deeper and deeper into it, I realized I was just regurgitating very similar kinds of philosophical arguments against this idea. And I think of these as arguments from incredulity. You'll say, well, how could this computer be conscious? If it has 1,000 steps and I make a copy of it on the first step and then I run it, is that second AI conscious in the same way? If I do it on the 500th step and I just copy it from the 500th step, is it going to be conscious? Or from the 999th step and I only do the last step? Actually, is it conscious? You can come up with all kinds of arguments like that. And, they're interesting philosophical arguments. Those are the kind of things that convinced me at that time, or gave me that really certain feeling that this can't possibly be true, because where's the information coming from to make this thing conscious? Like, all the parts don't have any history associated with them. So how would they know what happened to them before? And that was really my uh, underlying peeve with all of these statements. It didn't seem to consider how we get to this place of this unity of consciousness that we experience. That's actually another very important topic, and that's part of what all of this comes down to. What's tremendously weird about consciousness, though we take it for granted, is that it's a unity. If I see an apple, I don't have a red transistor go off and then an apple shaped transistor go off and a movement transistor go off. I see all of those bound together as a seamless whole.
Mm.
Yet we know that those different properties are actually processed in different parts of the brain. Or let me put it more accurately, we know that there are neurons in different parts of the visual cortex that respond to those different features. So, and then Within each of those areas, there are different neurons that are going to respond to different color stimuli from different parts of your visual field. So, what gives here? Um, how could it be that we have this unity of consciousness and yet all of the steps that we know about are distributed spatially and temporally? And then in a digital computer, that's even more, distributed. In fact, you've just got a little pipeline where one compute is done at a time, and the state of each transistor is only the state. It's just a voltage. A clock turns and then it changes to another one. Like, if you think about our AIs that we have today, I mean, they're probably a good representation there. I'm not saying whether only those can be conscious or other ones won't, but all AIs are going to have the same property, at least the ones on digital computers. They're going to have bits. Those bits are processed, and the state of those bits is a consequence of a sequence of events that are distributed, independent events that are distributed through space and time. And just to give people a picture of how vast this distribution of processes is, there are, I think, 12,288 floating point values that constitute a token in ChatGPT. And that's about 200,000 bits. All of them the consequence of different processes and events in the computer as data is shuttling back and forth, and each of them seemingly independent. Um, so that's called, figuring out why. Uh, the hard problem is really, in Chalmers' view, is why processes, why any of these processes should be associated with this internal subjective state that's all bound together. And
And
that's
the
why
consciousness denialists will just say, well, consciousness is an epiphenomena. And then, it's not that difficult to say, well, you have ontological representations of things, you have categorization of things, edge detection, for example, in vision models, just as a practical means for operating in the world.
still doesn't explain why there's an illusion. There's an infinite regress. But then why is there the illusion at all? Well, the illusion's an illusion. Well, why is there an illusion of an illusion? And continuously pointing to steps of processing is just unresponsive to the question. Or they actually are not conscious.
Hmm.
And I say that, it's a little tongue in cheek, but it's actually a possibility, and it might explain some things. Like, I have aphantasia. I had no idea. A friend of mine, a CTO, said another friend who also happens to be a CTO. I was CTO. He was saying, he was telling me that, you know, he was telling me, look, hey, Aneil, I have this thing I just discovered because my friend Theo, he also discovered he has this thing where when he closes his eyes and he tries to imagine some object, he doesn't see anything. It's just black. And apparently everybody else can see things in their mind's eye. I said, what? Everybody else can see things in their mind. What are you talking about? And, I was really surprised that it would be very shocking if you've never had a certain type of conscious experience and somebody tells you that it exists. How would you even interpret that? It's because I do have other conscious experiences that I can relate to that. But what would it be like for somebody who really is denying it because they're just a real philosophical zombie? What if they are? It's possible because I am in part. And so, what if there's some damage to whatever system actually produces consciousness? What if they are like LLMs? Formal possibility. I think they're just being difficult, to tell you the truth. I think they're just being difficult and argumentative. I just don't take illusionism seriously at all.
So I want to get into the problem of computational intractability. for what consciousness means. Because I think this is also we'll eventually get to the part about why LLMs, even though they can seem conscious, are not actually. But I think we have to actually understand a little bit about what's going on in the brain and this problem of Turing machines being conscious more generally before we start talking about the specific case of LLMs.
Yeah. Huh. Well, the way I look at it is computers are things we designed, and we know how they operate because we design them. And we design them to behave as systems of classical objects. If they weren't that, if transistors weren't well behaved, computers wouldn't work. So, you know, we know that, apart from some errors, but we eliminate all of those errors. We eliminate any weird effects in computers. So we know by design, like after decades and decades of testing these systems, that they behave in a manner that's consistent with local realism. A transistor turns on, it causes another transistor to turn on. That's how logic circuits work. And we could formalize those on paper. We can implement them in many, many other systems as long as these mechanical properties are obeyed. You could make a computer out of gears, and that's what Turing proposed, right? When he he wrote his famous paper, which defined the A machine, the automatic machine, which was a big ticker tape, and had 5 states, I think, and then he could read and write from the piece of paper. He showed that you could do general computation, and then he got together with this guy, Alonzo Church, who, created this thing called lambda calculus, which was a formalism for describing what functions do. And what they realized then was that his formal pen and paper system was equivalent in its computational powers to a Turing machine. And that's when this notion of Turing completeness was discovered. I think I'm not sure who coined that notion, but they noticed that there was this class of objects that, or even formal systems that would have equivalent states essentially. And so that's why you can simulate a PC on a Mac and so on and so forth.
Yeah. Or with
It's
Magic the Gathering, by the way.
Or Magic the Gathering, or simulate a Mac in Minecraft, maybe, because
Hmm.
you can even make computers using the objects in the game Minecraft.
Hmm.
So you can find computers in all kinds of systems because they're just, in a sense, they're just simple mechanical arrangements of a few different component parts. Like you could very plausibly take your lawnmower and turn it into a computer, like your memory with you need to use a lot of steel or aluminum or whatever to create your memory in such a system, but it would be computationally just as powerful as our fastest chips. It would be slower and more energy consumptive, but in principle, mathematically, they're identical. So completeness. It was interesting that Turing wrote that paper and to answer questions about whether problems are always answerable. And what he found is that there were questions that could be posed where the system would halt or not halt, and there were some problems that would not halt. And that was an answer. They kind of created computers, or the notion of computers, out of answering this fundamental question that was posed by David Hilbert about whether mathematics was complete and we could make proofs with formal systems. And the answer was no. And it was kind of very similar in spirit to the work that Kurt Gödel did. And what that shows is that these formal systems are incomplete in formulating certain proofs. And as Gödel showed, there are statements that you can know to be true outside of a system that, when represented in the system, cannot be proven. So, in that sense, these all of these formal systems, including computers, are incomplete. And that was something that Roger Penrose really honed in on when he proposed this first model of quantum consciousness, because he said, well, we know these things are true, so therefore our consciousness must not be a formal system like a computer. It must be something else. And what are those things that are something else that are not mechanical? And he made this argument for um, the idea that consciousness is quantum in some way. And then later he met Stuart Hameroff, who's the fellow who runs the Science of Consciousness conference now. And they came up with this theory about microtubules having quantum and, supporting quantum entangled states and maybe being the basis for consciousness.
Right. So go continue.
No, that's pretty much. I'm not sure if I really answered your question, but you were asking me about computability and the limits of computation. I mean, I I think that that is proof that AIs can't be conscious? I mean, it might be, but I think that there are objections to that, which are that perhaps we are a formal system that has enough axioms to see the things in the smaller systems that are obviously true, but not provable by them. And we can't see the things that are obviously true, but not provable by our formal system. I'm not sure if I've heard a rejoinder to that, but that seems like the obvious objection to me. And in any case, that argument really hasn't landed with people. It feels a little, sort of off the core understanding of the problem. It's almost like the argument as a little bit of a sleight of hand trick. I don't know. I'm kind of neutral on it. I'm just trying to interpret why that argument, didn't really carry the day with people.
Yeah, it strikes me as again just kind of like avoiding the discussion to just be like, well, maybe we are a formal system and therefore we cannot understand our own consciousness within the constraints of the system, right?
Yeah.
Or yeah, within the definition of the system. So you, what I'm trying to lead you into is this computational intractability concept, which we got to last time. So
Oh, that actually is a little bit of a different route than I took in answering your question. So I'm
yeah,
sorry I misunderstood.
well, no,
Um,
it's great. It's good.
but
It's good to explain the history of Turing and Hilbert and Penrose and get people up to speed on that discussion. I think that the trouble here is that in all of these discussions, once you start diving into quantum states and quantum mechanics and you go really headfirst into that, then you start getting into dangerous territory in terms of you have to be very precise about what statements we can and can't make and what actually, in some cases, people are qualified to make. Um, Qualified in quotes because, uh, but you do have an argument that says that, it's not clear that you can get that you can get consciousness out of just the sheer energy with just the sheer energy and time that's required to run consciousness as a computation. And I'm interested in that.
yeah, look, the way I started with this was just really thinking about computers and how computers could be conscious and what it would take for computers to be conscious. And I kind of approached it as an engineer on behalf of nature. So, what would nature need to have in addition to the physical laws that we know in order for such systems to be conscious? I, you know, I think that there are so many of these theories of consciousness, and so many of them are poorly specified. People say things like consciousness is software running on the hardware of the brain. And it really doesn't mean anything. It's just metaphors. And there are so many metaphors and, sort of poorly defined concepts, I think, amongst many of these theories where people are taking for granted very high level concepts as though we can just talk about information flows or feedback loops. And because we're uttering those words, then we have a theory of consciousness. But really, the way I started approaching this, trying to think very carefully about what is a certain, like what will give us certainty? Because we've had, when Leibniz made his mill argument, um, it- he was he 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 did not he did not have the benefit of 200 theories of consciousness, which is about what we have now. And yet, his argument is one that we're still struggling with and we still haven't answered. And part of that is because we have all of these theories that are analogies and they're talking about high level concepts and we're just getting more and more theories. And so I thought like, well, nobody's really we're not eliminating the theories. Like we are starting to because people are doing experiments and there were some really interesting experiments just a few months ago that compared the two major theories of consciousness, and they both failed. They were global workspace theory and integrated information theory. Those are the two leading contenders, and they both had problems. Um, and but people can just spin up these theories and make claims. And I was thinking, well, how do we actually resolve this? Because if you're talking about metaphors and analogies, we get mired in all kinds of very long semantic arguments and philosophical arguments, and it's very, very, very difficult kinds of conversations. And so my approach was to say, well, look, physics governs the motion of matter. And therefore and we know, from our experiments that consciousness is associated with the brain, and that, in fact, perturbations of the matter cause perturbations in consciousness. So we know that there's a connection, and therefore, any theory of consciousness must be consistent with the laws of physics. That shouldn't be too controversial. That's pretty straightforward. But the thing that we have to be careful of is not just introducing new words that don't make contact with physics, like saying things like information flows or feedback loops without defining precisely what the specific additions to physics would be. And this is kind of what David Chalmers also had another very important contribution that I should mention. He coined this concept of psychophysical laws. And he said that conscious, in order to explain how processes, as he saw it, gave rise to consciousness, you would need to add new laws to physics in addition to the existing ones. And he said that those laws would be supervenient on the existing laws of physics. That is, everything works the way that we see it works. These classical systems operate just in the ordinary way. But now there are some new laws that basically sit on top of our existing mechanistic laws that govern the movement of individual particles. And then somehow there are these patterns of when you have the right feedback loop, or you have a flow of a sequence of events through into some global workspace, as global workspace theory claims, or you have some other constraints that IIT supposes, and there's a causal structure, as they say, amongst many, many different interacting components. Then there is consciousness. And so what David basically did is he said, in order to solve the explanatory gap, you need to. I'm not sure. Did we discuss that? The explanatory gap?
I can't recall.
Well, let me just to clarify for folks who are listening, the explanatory gap basically says, well, we can account for all of these things happening and we have rules of physics, but why should these things be accompanied by, some subjective phenomenon, which is very close to the hard problem. But, another way of thinking about this very precisely and mathematically, which is what I think we need to do, is to take a look at physics as a system of mathematical equations. And then those equations, they're basically range over these dimensions of like time and distance, space, mass, charge, and you can imagine a multidimensional mathematical space. And then that's what the laws of physics allow you to do: move around in that space, nothing more. And that's not something that's subject to philosophical debate. So the epistemological gap the explanatory gap, in my view, is not a philosophical idea. It's a mathematical truth. And so that's why David is completely correct in saying if you believe that there are these processes that are working just fine according to the laws of ordinary physics, then you do need to add some new laws on top of physics. And now, that's about where the field stops. And then so people don't actually take the what would it mean to actually add those things to physics part. What is happening is that we hear that there should be feedback loops or there should be recurrent processes. But what does that mean? Like those are words. And quantum physicists didn't say things are a little spooky. When they came up with quantum theory, they wrote equations and they said these are the computations that need to be done. That is what we need to do. And people may say, "Hey, we're not there. We're still trying to figure things out, and we will get there." But what my feeling was is that we can understand just based on the formal properties of all of these theories that they would make requirements on the laws of physics or the psychophysical laws. The psychophysical laws will have to have certain properties in order for these, what I call classical process theories of consciousness. That is where you have discrete objects like gears or transistors, or if you think neurons are just completely independent input output structures. Well, if you think consciousness is a result of that, well, that creates certain commitments for the kinds of things that you're going to have to add to physics. And those things, as I hope I can convince you and your audience, are just absolutely ridiculous. They're completely impossible, and they fly in the face of our existing physical laws and kind of standards we have for our physical laws. And that's why I'm very, very certain that, you know, classical models of consciousness cannot be right, and that digital computers absolutely cannot be conscious, because we know that they are classical systems because we designed them that way. The physics that's going on in the brain is something to be discovered. And so that's kind of how I frame the approach to the problem.
So what examples do you have of why these classical systems can't represent consciousness? Give me some concrete.
Yeah. So if you think about what are we talking about? I'm sorry, I'll be a little bit abstract just for a minute, and then I'll give you something concrete. If you think about what these psychophysical laws are saying, is that there is a neuron. Let's say that there's recurrent processing. So there are theories which say when there are a sequence of events that cause the same neuron to fire because of a feedback loop. That's an example of a pattern, right? A pattern in the sequence of events in the physical world. And the claim is that because there is this circular set of events where the same neuron is activated, therefore there will be consciousness. And, I'm highly simplifying, maybe people say, oh, it's a lot more complicated than that. But just even reasoning about that simple kind of system will teach us a lot about the kind of stuff we need to add to physics. Okay. And so what would we need to add? Well, for one thing, this is what's called a structural matching problem. And a that's something that's well known to computer scientists. Structural matching is hard. There are algorithms for this. There's, a very famous one called the subgraph isomorphism algorithm. And if you think about a set of events and think about their interactions as a graph of nodes and edges all connected to each other. What you're saying is, I need to find a certain pattern within this collection of events. Well, the first thing that I would point out is, well, in order to find patterns in data, you need to have the data. So where does that come from? And when is that computation done? Because those events, by the definition of the problem, are in the past. And they're somewhere else. So there are things that happened in the memory of the computer. There are things that happen in different places in the CPU at different times. So then there is something that needs to have access to a history. But how could that be? Like, the whole idea around these models is that they obey classical physics and they obey locality. And all of a sudden, right out of the gate, even before we've considered what they're saying, you have to violently violate locality. So I think that that's very strange. Like, there is another answer to it, which is that each particle is actually collecting a history of all of its interactions. And every time it interacts, then somehow those two histories are compared. And so that it would know when the same particle or the same neuron, was activated in the past, it could resolve it. Otherwise, how would it work? You can't just say that these patterns are detected. And what's especially, I think, clarifying about this is that finding patterns is fundamentally unlike any of the physical laws. So the update of state for any object has a time complexity, a constant time complexity. So, for example, when an atom is moving through space, uh, its position and momentum allow you to calculate the very next step with, that's with a constant time in terms of the amount of computation. But of course, there's not really computation going on. It's just evolving. All the pieces are just evolving over time, and they have these very simple properties. But what we're saying in these theories where it's a pattern of interactions is, we have to know all of those interactions somehow. And then at some point, the pattern is recognized. But recognizing patterns is a computational problem. And it's one that involves, searching solutions, maintaining state, and you do something called backtracking, because there are many different patterns that you get a partial solution. Oh, that's not the right one. You have to backtrack and say, well, maybe here's a match. And then you backtrack. There's no other way to do it. And to just simply say, oh, there's some pattern matching capability. Well, you have to explain how that mates with the laws of physics, where we have these discrete objects with discrete properties that obey local realism. You have to have access to the data and do this form of compute. And, like, compared to O1, that constant time complexity, subgraph isomorphism is known to be NP complete. And in fact, it grows exponentially with, I think the exponent is 3/2, with
Mhm.
the inputs to the system. And the number of inputs is the number of events. And what are the events you would have to consider in the case of a computer? Well, as David and other people have stated, computers, as we know, a computer can be big, it can be small, it can be fast, or it can be slow. That is, these events could, in principle, be strewn across the entire universe. So you could have a computer that is built across galaxies, where light signals travel between galaxies. And our laws of nature would then would have to find these supposed uh, patterns of the psychophysical laws and sort them across all interactions across universal time. This just seems crazy. I mean, this just completely unacceptable. And then, computation doesn't come for free. You have to move memory from one place to another. You have to check state. And so what's really being proposed without anybody saying it is that there's some giant computer in the sky that's all knowing and all computationally powerful, but also all judging. Because, you know, people like to talk about each of the neuron activates or the transistor activates. What exactly is a transistor? Do we need to have a definition of a transistor in our laws of physics? What constitutes a transistor? What constitutes an on state? So, this is something that we don't allow into laws of physics, which is arbitrary interpretation. Now, computers pose an especially difficult problem here because they can be constructed of all kinds of materials. You can make them out of the objects in the game Minecraft. You can make them out of pulleys or water valves or transistors, you name it. So then there's this question of what would qualify as each object? What would qualify as each state in order for these patterns to be realized and to be added to the laws of physics? I just can't see it. I think that, those are there are three fundamental problems, and it almost seems crazy when I'm talking about it. Is how can you've got to have it wrong? Like, how could that possibly be? That sounds so stupid. But nobody is actually taking it back to the physics and asking, how do we actually add psychophysical laws to our existing system of laws? You'd have to interpret the objects. If you think that it's actually a neuron, like, what is a neuron? What happens when it loses a receptor? Or you know how does the universe know? How would we have physical laws that accounted for such a thing? And sometimes people will resort to saying, oh, it's information flow. But this is just using words to cover up the fact that ultimately we've all agreed that this is physical matter that's moving. And in any case, whatever that substrate is, it needs to be able to distinguish a glass of water, which is running according to the same rules of physics as in the brain. So those laws, they have to distinguish the patterns of interactions here and in the sun and at the center of the earth from what's happening in brains. And that means ranging over a massive space of interactions over all space and time. And physics is very different. Physics has the current state, which is updated instantaneously with a constant time type of functioning. Things merely evolve over time. And so that's why I think that any of these, all in fact of the mainstream theories of consciousness, simply have absolutely no chance at being true. They can't without violating all of these properties of physics.
Wow. So we're now moving into the discussion of, I think, the machines themselves, the LLMs,
Yeah.
right? And it, because we could keep going down this rabbit hole of like why consciousness, why these theories of consciousness don't make sense, why the laws of physics are limited to them. But really, the core of this discussion and the reason for this discussion is to get to this issue of the consciousness of these intelligent machines, right? Because it has deep implications for humanity, for our futures, and also for, a tremendous amount of effort and resources that's being put into sort of trying to realize this vision. And if it's a vision that is misguided, then a lot of people and a lot of money is being basically I don't know about set on fire, but is being dumped into something that's ultimately going to not end up where they're purporting to end up. So
I'm a big fan of AI, I will say. So
Yeah.
I invest in AI. I think it's great. I think they're great tools. They're great machines. It's great software. And I think what people are doing in this space, building AI, is terrific. I am not a doomer. I'm very skeptical of the doom scenarios. I guess I shouldn't be super skeptical, but I'm somewhat skeptical of them. Um, and so I don't I think that there are practical solutions to dealing with these machines that are indeterminate and, have properties that are new. I certainly think that there are important, conversations to be had about that. But my concern has really been around the people who are saying, hey, they're conscious.
Yeah.
We need to give them rights. I think if there's a doom scenario for us, that is our doom.
It's the political economy of AIs. Yeah.
Absolutely right. Because, look, if we grant rights to things which are fundamentally not conscious, which well, I've shown that they can't be, then I believe AIs will be more capable than human beings on a lot of tasks. And so
Mhm.
if they're given political rights, if they're given labor rights, will you have to pay your AI? Or be accused of slavery? Will
Yeah,
you
can
have
you own an AI?
Yeah, can you own it? Are you not allowed to turn it off? Does it have the right to defend itself? There are all of these questions that are swirling around these, seemingly fun conversations that everybody is having around this topic. But I think that there are real serious dangers in this because, that's one example of it. It may seem fanciful, but, I would point to there was a fellow who ran for mayor and said he was going to make all of his decisions by AI. Uh, but I don't see any problem with that. But that's there that that could take several other steps. What if AIs can vote? And there was this recent case where character AI uh, was defending themselves against a wrongful death suit, and they were claiming that the AI should have free speech rights. So that made it to the courts, and thankfully it was rejected. It was a pretty cynical move to do that. But how long is it going to be before there's a misinformed jury, a misinformed judge who accepts that, and then we grant these mindless machines the same rights as humans, and then actual thinking, feeling, sentient beings will be competing economically and legally and politically with mindless elites. That's terrible. I mean, that's probably the biggest worry that we just shouldn't do that. And I also think that people should not be promoting this idea when this is such an uncertain idea because there are now many, many people who believe that they are or will be. There are people who are getting involved with thinking that their AIs are talking to them and that they have spiritual beings in them. And, I've heard stories about, successful entrepreneurs who've just, got messages from these machines. They think that there's consciousness in them and they've lost their businesses. They just stopped doing things and it's causing real delusions and harm. And then promoting this idea that, yes, they are conscious, they are going to be conscious is going to create tremendous social harm. People are going to form relationships with things which are fundamentally not conscious, thinking that they are. They're going to be subject to manipulation as a result of that.
Yeah.
There are just there's a world of terrible things. And, I would back this up, is this just a small cadre of people who thinks this? And I think that the answer is clearly no, because I think it was a Pew poll that was done that asked general public what they thought when they thought AI would be conscious, and the median answer was 5 years. So it's probably 4 years now. I think that was about a year ago. So people are thinking the message has gone out that they are conscious and will be conscious. That's all you hear on every podcast. And there are no cogent arguments against this. And, this is not my field, but I felt that I needed to speak about this because this is clearly wrong and dangerous. So that's how I got involved.
I want to push you more precisely on this, because certainly, when I'm talking to Claude, for example, Claude Desktop is my preferred model for casual tasks. I, it has a giant system prompt where Anthropic has all these safety measures put in, and tells it what not to say, and et cetera. But if I go through that system prompt and I start peeling back a lot of the assertions of like, you will not claim to be conscious, you will not, et cetera, to the user. I could certainly start having a conversation with it where it starts to emulate what seems like consciousness. And so where do I start to draw the line between, well, this, a human that tells me they're conscious is merely reporting their experience, and I can make this LLM at least emulate what looks like a reporting of its experience. I can ask it to draw an internal representation of itself in ASCII characters. So why is that not the same?
It's not the same for kind of the epistemological reasons that I laid out, which is we only have one example of consciousness and we grant it to, based on a careful consideration. And that consideration is that you, Alex, are structurally, compositionally, and operationally similar to me. And I know I have consciousness. And so I would grant consciousness to a cockroach much sooner than I would to a digital machine. Because what we know is that neurons, for sure, and I'm not saying neurons are the only form of matter that could produce consciousness, it's some kind of physics that's going on in there that the neurons are a medium for. And that would be my view of it. But we have to discover what the physics is before we can grant the status of sentience. We have to understand what the actual basis for the phenomenon. There's this great picture of a bunch of roosters looking at a red valve, and they have their red coxcombs, and they're kind of looking at it like they think it's a rooster. And that is basically what people are doing. We're being fooled by external appearances because most people don't even know what's going on inside, or they haven't thought about what, the goings on inside could possibly mean and whether they could be, constitute conscious experiences. I think that's why this argument is important. I think that people need to get serious about this from a scientific perspective instead of, like this is really a question for physicists who are working with real model systems. Like a biologist, this is a natural phenomenon, right? Like we know it happens in biology for sure, right? At least in us, or at least, ourselves, et cetera, that whole line of reasoning. And the question is, how does it happen there? And what a biologist does is when they see some natural phenomena that they want to study, they create a model system. And they have to make a case for whether that model system is suitable for the experiments they're doing. And then some scientists will say, no, that doesn't represent the phenomenon. You're just studying some weird artifact. Get out of here. Like a biologist wouldn't do the following and say, look under their microscope, see a cell, and say, look, the cell is round, and then go out to their yard and find a rock, which is also round, and then decide that they're studying cell division. That would be crazy. But that is essentially what we're doing by just looking at the very surface level appearances when we don't understand the production or the capture of this physical phenomenon in the real model systems. And the only real model systems for studying this until we can get further are human beings. Like there are some other examples of it, but it has to be biological matter. And there are some interesting experiments. Like I'll give you another example other than, people with, awake during brain surgery. There are easier experiments, maybe. There are some proposals to take organoids, which are clumps of cells, which are similar to organs in the body, and brain organoids specifically, and attempt to get entanglement with them. Now, I don't know what that means in an experimental setup or how that's done, but there are very credible people who are working on that. That was, I think that's Hartmut Neven, who's the head of quantum computing at Google. So I will take him at his word that he has a real experiment to do on that. Seems like a really hard experiment, but I haven't set up systems to do quantum entanglement. But that's potentially a kind of question where you could ask whether a certain type of physical phenomena is actually present inside biological matter, and that would at least open the door to saying, well, these phenomena are present. And Stuart Hameroff and his colleagues have been making the case that there are quantum entangled states in microtubules. um, Jury's still out for me a little bit, but there is some compelling evidence that there may be quantum processes. We know that uh, there are lots of quantum processes in biology, but they tend to be little hops of like tunneling of electrons during photosynthesis, so, things of that nature. And we haven't really, I mean, I think that there's some research that argues that there are large scale entangled states in microtubules, but we would still have to get out of microtubules through synapses and into other neurons in order to actually account for all of these different signals that are distributed through the brain. It is a super, super hard problem. I mean, technically I don't see how it works either. Like the quantum hypothesis is very, very tenuous to me too, because, quantum entangled states, if we believe that they're that, and I haven't really explained why I think maybe that's a solution to the problem, but if you believe that that's the case, you still have to account for this binding problem where you have all of these different processes happening in different parts of the brain, and then they have to admit to some sort of process that we understand actually occurs in physics that allows that information or that state to be integrated. I guess this is, I mean, I mentioned quantum and we've talked about quantum, so I should maybe explain a little bit about that.
Yeah, let's touch on the quantum. I mean, for lack of a better term, quantum consciousness. That term gets thrown around a lot these days. But you have a serious uh, explanation or argument as to why consciousness appears to be uh, a state, a quantum state of some kind.
Well, I think it's more the eliminative argument uh, from analyzing classical systems. The classical systems can't be. And I think, generally the whole field agrees that you need more than just the data in one particle to account for the complexity of our phenomenal experience. There are different estimates for how many bits per second we experience in consciousness, and the way people are coming up with this is a big guess. Some of there are some studies that talk about the number of precepts that are available to a conscious person, of maybe features that they can describe, but that's pretty high level. And you think, I've forgotten how many gigabytes. That's a huge number of gigabytes of information that the photoreceptors actually capture. And so you got this high res screen that you're looking at. Now, all of that may not actually make it to consciousness, but I think that we can agree it seems like we have a lot of pixels that we are enjoying when we look out into the world. And so you need to have an account for how all of those pixels, where the information for all of those pixels gets joined and bound together. And so if you can't find it in processes, which are distributed through space and time, the other option is instead of processes, you could have state. That there is actually a sort of some way that the state of matter rather than the history of matter accounts for this phenomena that we're experiencing, that you might look at it like a form of field where the parts are joined together. And that's the one place that we find that phenomenologically is in quantum physics, where you have entangled systems. And that's really my argument is only that far to it. It's just to say we need something like this. So therefore, this is the one place that I can think of looking. I should say that there's another type of model, which are also in principle, they're classical models, but they're not classical process models. So these are electromagnetic field models. So there are people like Andre Gomez Emelson at the Qualia Research Institute has been promoting and talking about electromagnetic field topology. I don't quite know how to think about a model like this. He says that, but there's some interesting things going for it. That the brain, there are synchronous states between different hemispheres of the brain that seem to correlate with conscious experience. And it may be that they're setting up some sort of electromagnetic field, and this field has a topology similar to how the sun, has magnetic field lines, and you can actually define and see a structure within that, within the field. I don't know how to evaluate this yet, and I haven't really applied myself to thinking about whether that gets around my objections, because a classical field, does it know about the state of, the some part of the field? Like our classical description of it says no, that every point is only affected by the points that are near it. But maybe, I'm open to it that a field is a continuous medium. And so maybe we just have a wrong model for fields, and they actually do have some sort of coherent structure. And that might be a way of thinking about it as well. So I don't want to say that it's definitely quantum. I'm mainly just trying to exclude all of the mainstream classical theories of consciousness. But we need something that does solve the integration problem. And so the integrated information theory guys have it basically right. I just think that it can't be processes.
Hmm. So you work also in AI and biology, health tech specifically. You invest there. What are you most excited about at this intersection?
Oh, well, that's very interesting. A change of pace. Well, right about the time that ChatGPT was launching, it was a little bit before it really hit. Um, I started looking at, the attention is all you need paper and other related papers with friends. I'd never really, stupidly, been very drawn to AI because I'd seen AI for years being used merely as a classifier, just distinguishing one, you know, set of points in data from another. And it was just like a fancy machine learning toolkit, really. And, I started figuring out something really interesting was going on, uh, where there was something new happening, and generative, this capability to do generative AI was new. And I'd known about these problems of the vanishing gradient problem, where you cannot train these systems very deep, um, because, the a differential that you need to update the weights deeper into the network disappears with deeper networks. And that was the case for a long time. And we didn't have all of these, interesting techniques from generative and so on and so forth. But then things started changing, and I really started thinking about, like, wait a minute, there's something fundamental that has changed here. And I started going over with friends in Silicon Valley, like where are all the pieces that are being brought to bear? And is this just something that works for text processing, or is there something more fundamental that's happened? And I definitely had the feeling that, look, there's something fundamental because specifically because we're able to really do deep learning and not just shallow learning, which is where we were for a long time. And yeah, I started, taking a look at all of the different techniques, and I started getting convinced that this was going to be a very, very general and powerful tool, and that it would apply to many, many different areas and many different data sets, and we would have many other techniques than transformers that would enable this. Interestingly enough, one of the things that really blew me away is that the reason that deep learning works, and I don't know if people talk about this too much, is it's really because of a dirty hack, which is that there are these LRUs or linear rectified units, which just means that it's a conditional statement that says if the value is less than zero, set it to zero. Okay, that's it. That's what an LRU is. And it just reifies the outputs so that it gets rid of the vanishing gradient problem. Now, this is a violation of the beautiful theory that Geoffrey Hinton taught the world, which is that the backpropagation algorithm is essentially an implementation of the chain rule, which would not allow this type of function in it. You can't make sense mathematically of a system when you have a conditional statement like this because it's a nonlinear function, or it's a non-continuous function. And so anyway, that dirty hack, I kind of is an unsung hero in my view of our progress in AI. I just want to give it a shout out. So anyway, that all of that sort of led me to thinking about, my field, which is biology. And it struck me that, there's no more complicated form of data or forms of data than biology. It's easily the most complex set of data sets that we have are due to biology. And AI is especially good at finding useful patterns in complex data. And that insight said, we are not just going to see things like AlphaFold. We're not just going to see, the innovations that DeepMind has produced. We are going to see a flourishing of all kinds of opportunities in this space. And we would be able to do what I think we sort of thought we were heading in the direction of at the systems biology department, which is to make biology an engineerable substrate. And it's AI that's going to give us that power. Like we are now designing drugs that we couldn't design before. And those are the smallest, tiniest little elements. But we're also now designing proteins. We are designing cells. And we're also monitoring the entire, time variant behavior of people's bodies and the proteins in their blood. And we're doing this dynamically, and we have kits and wearables and blood monitoring devices and, rings, and we'll have EEG systems that will monitor all of this data, brain waves, your heart rate. We already have many of these things, but that's going to be collected, and AI is going to make sense of that. And we're going to not just build better therapeutics, we're also going to build, consumer devices. And I think that there are going to be new models that we have for how healthcare is delivered. And it's going to be a massive, massive wave where, like the way I think about it is biology is turning into an engineering platform. You could think about this as a coming age of biology.
Mm.
It's like the birth of the internet, and it's so different and so weird compared to what we think about in tech. But it is, in fact, now it's emerging from being a place where we do research and then develop drugs to using it to create products. And so that's really where I think there are going to be massive, massive opportunities in the space. And there are a lot of other people think that too. That's not any unique insight at all, obviously, but that's what got us into it.
Oh, that's fantastic. Yeah, it's really exciting space. It's a really exciting time to be alive, really, if you just start projecting out where this could go in 5, 10 years. Because biology has really been um, kind of in the laboratory for a very long time, and now we actually have the opportunity, as you said, to sort of bring it into engineering, and that presents all kinds of uh,
For
advances in consumer and medical. Um, and yeah, it's uh, incredible time to be alive.
Yeah, it's really amazing, and I think it's just very interesting to think about what it's going to do for longevity and preventive health. Because right now we look at medicine and healthcare as something to treat us when we're sick. But what if we could monitor and find those things and tune them way before we get sick? Like, that's also the opportunity in the space. So there, you know, new products that we're going to make. I spoke with somebody who was talking about making proteins that could digest harmful components in our food. There are all kinds of amazing innovations I think we're going to see that we don't even understand what the scope of them is. Just the low hanging fruits are so amazing that we're all stunned by them. But as people become comfortable with this idea and comfortable with the tools, they'll become even more innovative. And there's just going to be, you know, wild new possibilities, I think, in the future.
Well, Neil, I'm based in Austin. I met you here in Austin. I don't know. I assume you spend a good amount of your time in Austin as well as elsewhere. What is your view on Austin specifically as a city for uh, AI, for tech innovation, for investment and startups, as compared to, say, San Francisco, New York?
Well, I love Austin so much. I I just absolutely love the people here. When we first got here from the Bay Area, I thought we have to go back. It's too hot. We hadn't found our tribe. And, it takes a little while to sink into a place. And there's something really, really amazing that's going on here culturally, because people are very open, it's very heterogeneous, and people are very friendly. And that creates an environment that's conducive to exploring new spaces. And that's what any startup needs. Startup needs not to go head to head with the big behemoths. They find a new category and they dig into that category and they become known for it. And I think that that is probably the right path for Austin. It is very hard to compete with the established areas. There is an energy in San Francisco and just an intensity, which leads to faster learning loops. There are events constantly in San Francisco that are very deep on the topic of AI, new techniques, cultural changes. And I don't think it's for Austin to compete head to head with that. Um, but Austin has some great scientists at the university, and it has this culture that is exploring a lot of very interesting and anomalous ideas here. There are a lot of people who are very open spiritually. There are a lot of neurotech companies here, interestingly, as well. And so my view is that this science of the mind is going to be one of the major areas of cultural, scientific, and political evolution for a whole species. It's actually the place where, we confront these problems of raw materialism, just like in analyzing AI and understanding what its limits are, and you realize there's actually something else. And that's a very profound idea, that our ontology of the world is incomplete, that there may be other causes other than these material ones, that it's not just matter in motion, there may be something else. Now, whether consciousness affects the world, I think it does. And I think that there's an argument to say that your conscious awareness actually impacts the world and it's not epiphenomenal. This is sort of a crazy answer to your question. But if that's true, and I believe it's true, then that means that there is a whole other culture that we start to build, which is considering the contents of consciousness, not just as feelings that are epiphenomenal, but actually something that does work in the world. Um, so I don't know what that means. That's a very wild and woolly answer. But I think that there's going to be a lot of firmament. The ordinary answer is neurotech's great, AI and the brain is great. But I think that there's something much deeper beyond that, where people will start to explore consciousness. And I think that Austin could be a major center for innovation in that space. I really do. I think it's an incredible city for this to happen in, because the culture is right for it. That's the thing that the coasts don't have. The coasts are very materially minded and bound into the old model. And there are so many people here in Austin that are like bursting with the energy to explore these new areas. I think that's super exciting.
Well, Aneil, thank you so much for coming on the show. It's been an absolute pleasure.
Yeah, it's been really fun, Alex. Nice seeing you again.
Yeah, I'm so glad we got the chance to do this.
Yeah, me too. Thanks.
See ya.